All right, so two-step conversions. Two-step mole conversions are the same concept as one-step mole conversions. You're just doing it twice, okay? So if we look at our mole roadmap, which is actually the page I wanted to be on, back here, all what we did last class were one-step conversions. We were either converting to or from moles. Now these two-step conversions are going to be things like volume to mass, or mass to particles, or particles to volume, or whatever, okay? Notice that intermediate step, the middle step, is always going to be moles. You're always going to have to go to moles first, and then from moles to whatever else you're looking at. Notice like there's no direct conversion between volume and mass, or particles and volume, okay? We don't have those direct conversions. It's always through moles. Think of moles as your pit stop, okay? The whole roadmap analogy, driving and stuff. Moles is always going to be your pit stop. It's always going to be your transfer point to something else, okay? So same concepts before in terms of our conversion. So let's look at this first one. We have 5.631 times 10 to the 21st atoms of sodium, and we are converting to grams of sodium. So let's write out our roadmap. It's going to have two steps to it, though. Atoms is a type of what? Particle. So we're starting at particles, and we're eventually getting to mass, but where do we have to go first? Moles. And then we will go to mass. What information do we use to go from particles to moles? Avogadro's number. And what do we use to go from moles to mass? MM on the PT, molar mass on the periodic table. All right, so when we set this up, we're going to set it up as one big long problem. It'll take up about twice the amount of space as a one-step conversion does. So make sure you don't, make sure you leave enough space on your paper. So we're starting with 5.631 times 10 to the 21st atoms of sodium. Okay. Same concept where we're going to, when we set up our conversion, whatever unit we have here that we're starting with needs to go on the bottom, so it'll cancel. So atoms of sodium go on the bottom, and the unit we're converting to goes on the top. Well, we're first converting from atoms to what? Moles. So moles of sodium go on the top. In our next step, we'll go from moles to mass. What number goes with moles? 1. You're always going to put a 1 with moles until I tell you otherwise, okay, until unit 7. And what number goes with atoms? 6.02 times 10 to the 23rd. Avogadro's number. If we were to stop the problem here, we would be solving for moles of sodium, but that's not what I asked us to find. We have to then do another step from moles to mass. So we've taken care of this first step. Now we have to do the second one. So we're going to multiply by another conversion. What unit will go on the bottom here? Moles, because we want moles to cancel. And what unit goes on the top? Grams of sodium. And what number do we put with mole? 1, just like before. And then the mass, the grams of sodium, is the molar mass from the periodic table. Remember, when you pull things from the periodic table, we're always going to do 2 decimal places. Just makes it nice and simple. So what is sodium's mass to 2 decimal places? 22.99. So that would take care of moles of sodium. So we've handled the second step. And now we're ready to solve. So it doesn't matter if, really, you're taking this 5.631 times 10 to the 21st, you're multiplying it by the molar mass, the 22.99, and you're dividing it by Avogadro's number, 6.02 times 10 to the 23rd. in terms of like the order of operations, it doesn't matter if you do the multiplication first or the division first, okay? Because it's the same like type of process. So in like the order of operations, like parentheses, exponent, blah, 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 multiplication and division can occur in either order. I typically go left to right so that I hit them as I read left to right. So I do my division first and then my multiplication. But again, it doesn't matter. You're going to get the same answer. Okay? How many sig figs are we going to have in our answer? 4. That 5.631 times 10 to the 21st, we have 4 sig figs, the 5, 6, 3, and the 1. So when you do the math, make sure you get the proper sig figs. And again, putting the number in scientific notation into your calculator correctly is key. Remember, use that E button. The E button is found above the 7. It's the second of the comma, the second function of comma. So please do that as you're typing it in. Make sure you're using the E button correctly. And what do we get? Anyone there yet?
Can't say even. Okay, I got. Okay, can you give me like a range? Make sure I didn't mess up. And I'll show it to you. I don't want to do this. Is this?
Yes.
It's 0.2150
And what are your units?
grams
Of?
of sodium.
Grams of sodium. Good. 0.2150 grams. Now, if you did not get that, when we break off into practicing these with our pods, I will come back around and I will help you. I'll show you how to use the calculator properly, okay? So if you didn't quite get that, if you got like 2.150, blah, 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 times 10 to like the 46th or the 44th, something like that, that's because you didn't put in your calculator properly, and I'll fix that in a little bit, okay? If you got this, you're good. Just keep doing it the way you were doing it. All right? All right, let's do the next one. Now, with this next one, I am not cussing at you in this problem. Okay? I'm not cussing at you. The FU stands for formula units. Okay? And that is the ionic compound particle. That is the particle of an ionic compound. It's called a formula unit. Again, it's just terminology. Process is the same. But I just want to point out that I'm not cussing at you. And I will understand when you write FU on a paper, I will assume you mean formula units. Okay? All right, so our roadmap. Where are we starting with this one? Particles. Where do we go first? Moles. How do we get there? Avogadro's number. And then we go mole to mass using mm on the PT. Now, what do you notice about this roadmap compared to the last roadmap?
Same.
It's the same. So the process is going to actually be the same, just your numbers are going to be different. Okay? So why don't you guys work on, this is going to be the first like pod activity. I want you guys to solve this one the rest of the way. Okay? Since it's the exact same process, use number 7 as your template. All right, so now that you've had some time to do this problem, let's go through it again, and then I'll have you guys do the other 3 in your pods, okay? So we're starting with 1.5 times 10 to the 22nd formula units, or FU, of CaOH2. What's our first step going to look like? What's our first conversion going to look like? Moles over FU, so moles of calcium hydroxide over formula units of calcium hydroxide. And what are the numbers? 1 over 6.02 times 10 to the 23rd. Guys, can you wait to ask your questions? And then our second step is going to look like what? Mass over moles. What unit is our mass in? Because mass is the type of measurement, but we measure mass in what unit? Grams. What goes with moles? 1. And what is the molar mass of CaOH2? 74.10. All right, and at this point we've canceled, formula units cancel, moles cancel, and we're left with grams. So if you haven't already, which you should have, do the math there. How many sig figs are we going to have? How many? 2, good, because 1.5 times 10 to the 22nd only has 2 sig figs. Whatever comes before, it's up to the scientific notation. And what do you get? 1.8 grams of CaOH2. Okay?